Hey everyone, welcome to The Explainer. Today we're going to unravel a gripping, real-life medical detective story. We're looking at a microscopic pathogen that has completely baffled brilliant minds, struck fear on historic battlefields, and, crazy enough, continues to quietly circulate right in our very own backyards today. Yep, we're talking about the hantavirus. I am so thrilled to guide you through the fascinating biology, the incredible historical breakthroughs, and the practical science of exactly how this virus operates. Together, we're going to see how this invisible threat works and, more importantly, how we can defend ourselves against it. Let's get started.
Okay, let's dive right into this. Picture it. The year is 1951. The world is gripped by the Korean War. But alongside the devastating combat, there's this unseen enemy stalking the front lines. Around 3,200 United Nations troops stationed near the Hantan River suddenly come down with a terrifying, totally unexplained illness. They're suffering from high fevers, sudden kidney failure, and internal bleeding. And at the time, doctors are completely helpless. They have absolutely no idea what's causing this devastating Korean hemorrhagic fever. Was it a weapon, some new parasite, a poisoned water supply? For decades, the true culprit remained a complete ghost.
Part 1. Mystery Disease of the Battlefield.
So for decades, this battlefield affliction wasn't just a military problem. It was this profound scientific mystery. The virus was causing massive disruption, yet it remained incredibly elusive. After that initial 1951 outbreak, 25 years passed with zero answers. Then, finally, in 1976, we get a major breakthrough. A brilliant South Korean virologist named Dr. Ho-Wong Lee was examining the lungs of striped field mice caught near that same Hantan River. And boom, he discovers an antigen in the rodents that perfectly reacted with the antibodies from the soldiers who had survived the illness years prior. It's like finding a fingerprint at a 25-year-old crime scene. By 1978, the virus was successfully isolated and officially named the Hantan virus. The wartime mystery was finally solved. But just when scientists thought they had a handle on this thing, a sudden 1993 outbreak in the American Southwest proved that this pathogen had way more tricks up its sleeve.
Part 2. Lethal New Threat in America.
That 1993 event dramatically shifted everything we thought we knew. Over in the Four Corners region of the U.S., where Utah, Colorado, Arizona, and New Mexico meet, young, totally healthy people suddenly started falling ill with severe respiratory distress. It became incredibly clear this was a global threat, which virologists now categorize into two camps. On one side, we've got the Old World viruses, found over in Eurasia and Africa, which cause hemorrhagic fever with renal syndrome, or HFRS. This is the illness the soldiers experienced, primarily attacking the kidneys, with a fatality rate anywhere from less than 1% up to 15%. But on the other side, we have the New World viruses, like the Sinambri virus discovered in the Americas during that 93 outbreak. This one causes hantavirus pulmonary syndrome, or HPS, and instead of the kidneys, it aggressively targets the lungs and the heart.
And here is the truly terrifying reality of hantavirus pulmonary syndrome. It carries a staggering fatality rate of 30 to 60%. Just let that sink in for a second. 30 to 60%. And what's completely mind-blowing about this is the cinematic contrast in the biology. Inside its natural rodent host, like the common deer mouse, the virus is essentially harmless. It just lives and replicates without causing the mouse any symptoms at all. But the very second it crosses over into a human host, it triggers a catastrophic, highly lethal immune reaction.
Part 3. Infection Crossing Species Barriers.
Now, what's really interesting here is how exactly does a virus that quietly hitches a ride inside a tiny field mouse end up causing a life-threatening crisis in a human being? Well, it's a bit of a biological heist. First, the asymptomatic infected rodent goes about its life, leaving behind droppings, urine, and saliva. Second, and this is the crucial stage, these excretions dry out. The virus particles become aerosolized. They just mix right in with ordinary dust. And astonishingly, this virus can survive sitting at room temperature for over 10 days. Third, a human comes along. Maybe you're sweeping out an old shed or hiking through some dry brush, and you inhale this contaminated dust. It's literally a microscopic Trojan horse. Finally, once inhaled, the virus travels deep down into the lungs and attaches itself directly to human endothelial cells.
Part 4. How pulmonary syndrome destroys bodies.
Once the virus has successfully breached our defenses, the clock really starts ticking. The primary victims of this viral hijacking are our endothelial cells, those are the ones lining our blood vessels, and our macrophages, which are our key immune cells. The hantavirus is coated in these specific surface glycoprotein spikes, known as GN and GC. Think of these spikes like perfectly cut keys that bind specifically to beta-3 integrin receptors on our human cells. Once it's attached, the virus gets pulled inside, cracks open, and completely hijacks the host's cellular machinery to replicate itself. But the real danger isn't actually just the virus multiplying, it's how our body reacts to it. The infection severely damages the integrity of those blood vessel walls and triggers a massive, overwhelming overreaction from our own immune system.
Because those endothelial cells lining the blood vessels are so compromised, they begin to leak. In the cardiopulmonary phase of HPS, this leads to a rapid pulmonary capillary leak. Basically, blood plasma seeps out of the vessels and dumps directly into the air sacs of the lungs. This causes massive fluid accumulation, which doctors call pulmonary edema. Literally within hours, a perfectly healthy person can go from feeling like they just have a mild flu to experiencing acute respiratory failure and sudden shock, all because their lungs are literally filling with their own fluids. It is a rapid and absolutely terrifying progression.
Part 5. Butterfly Effect of Environmental Destruction.
But you know, viruses don't just exist in a vacuum. These outbreaks are entirely driven by our shifting environment. For instance, that 1993 Four Corners outbreak, it wasn't random at all. It was actually preceded by an El Niño climate phenomenon, which brought unusually heavy rains to a very dry region. That rain caused a massive boom in vegetation and pine nuts, which in turn caused the local deer mouse population to absolutely explode. More mice meant more virus. And beyond just climate, we also have massive human activity to consider. Deforestation and expanding agriculture strip away natural habitats while simultaneously providing these massive sources of animal feed. This basically forces wild, potentially infected rodents right into our barns, our sheds, and our human settlements. We are artificially increasing the contact zones between humans and rodents.
Part 6. Essential Daily Prevention Guidelines.
Because we understand exactly how these environmental factors push rodents into our spaces, we are not powerless here. Far from it. We can dramatically reduce our risk by focusing on some really practical, everyday defense strategies. First up, simply avoid contact with rodent habitats. If you see a nest, do not disturb it without the proper precautions. Second, strictly manage your solid waste and garbage. Leftover trash is just a magnet for foraging mice. Third, and this is highly critical if you're a hiker, farmer, or live in a rural area, wear masks in dusty, enclosed environments. If you're sweeping out an old cabin or a barn, mask up. Remember, the virus lives in aerosolized dust, right? Fourth, securely store all agricultural animal feed in thick, rodent-proof containers. And finally, just maintain clean, sanitary living conditions to ensure rodents have absolutely no reason to move in with you in the first place.
As we wrap up this explainer, I really want to leave you with a thought-provoking question. We've seen how the hantavirus evolved from this baffling battlefield mystery into a modern medical challenge, jumping from completely asymptomatic mice to cause devastating illness in humans. But ultimately, outbreaks aren't just biological events, are they? They're ecological ones. As our human footprint continues to expand deeper and deeper into nature, encountering these pathogens is basically inevitable. By respecting the science, understanding the transmission cycle, and adapting our daily habits, we can strike a balance between public health and the natural world. Thank you so much for joining me today and diving into the fascinating world of the hantavirus. Stay curious, stay safe, and I will see you in the next explainer.